Morning and welcome to my third tutorials in advanced database. My name is Dr. Thomas Yeboah from Christian Service University College. The topic that we are going to consider for today's lecture is relational query language. So when we talk about the relational query language, it's not anything but those things or those aspects of database that enable us to retrieve or manipulate the database being created. So this is the main topic that we are going to consider for today's lecture: relational query language. The query languages allow manipulation and retrieval of data from a database. So once you are able to create a database, the next thing that you're supposed to do is to manipulate the database. Whether you want to retrieve something from the database or you want to delete something from the database, then we need a relational query language to perform those jobs. Now, talking about relational query languages, there are two mathematical query languages that we are going to consider under this topic, and these are relational algebra and relational calculus. So these are the mathematical query languages that we are going to consider under relational query languages. So we have relational algebra and relational calculus. So the difference between the two is that the relational algebra is procedural and the relational calculus is non-procedural. You see, for now, just take it like this. But when we take the individual topics, that's the relational algebra and the relational calculus, then you understand it into details. So first, let us look at relational algebra. Relational algebra is the basic set of operations for the relational model. So the relational algebra is supposed to be the basic set of operations for the relational model. These operations enable a user to specify the basic retrieval request. So without the knowledge of the relational algebra, the user will find it very difficult to understand or ask the database a question. So that is why it is necessary for us to look at the relational algebra. Now, before we move, then let us look at the relational algebra overview. So under the relational algebra, I want us to look at the things that we are going to consider. So relational algebra consists of several groups of operations. The relational algebra consists of several groups of operations. Number one, unary relational operations. And when you talk about the unary relational operations, it includes the following: selection, projection, and rename. These are the unary relational operations. So then the next one will be relational algebra operation from set theory. So relational algebra operation from set theory. So that one we are going to consider union, intersection, difference, and the product. So under the relational algebra operation from set theory, you'll be looking at union, intersection, difference, difference or minus, and the product or multiplication. And the binary relational operations, you're also going to look at binary relational operation, and that one also includes joins and divisions. So this is the overview of the relational algebra. You'll be looking at binary relational operations, which include selection, projection, and the renaming. Then the next one, relational algebra operations from set theory, and that one also includes union, intersection, difference, and the product. And the last one will be binary relational operations. That one includes joins and the divisions. Now in this lecture, we'll be using the following tables to illustrate our examples. So we'll be using the following tables for our examples. So as you can see there, first of all, let me take a pointer so that you get it well. So we have relation S1 and we have relation S2. So relation S1 is having SID, SName, rating, age. And relation S2 is also having the same SID, SName, rating, and age. and the next one will be R1, which is also having SID, BID, and the day. So these are the relations or the tables that we are going to use to demonstrate the various operations. SI, S1, S2, and R1. These are the tables. Now, relational algebra basic operations, like we said, we have selections, we have projection, and we have product, and the difference, and the unit. So these are the basic operations that we are going to consider. Now, when we talk about selection, the selection is supposed to select a subset of a rule from a relations. For example, let's say you are looking at a particular student. Let's say a table called student, and you are looking at a particular student. So you see, you want to pick a particular rule from the table, or a particular rule from the relation. And in that case, you have to use a selection command. So selection command, this is the symbol, and you're supposed to select a subset of rows from a relation. So for example, we can have a row, 100 rows, and we are only interested in let's say 3 rows, or those that satisfy a certain condition. In that case, you need to use a selection command. Now the next item that you'll be looking at is what? Projection. And for the projection, it's supposed to delete unwanted column from a relation. For example, let's say you have about 5 columns for a particular table or for a particular relation, and but you are only interested in, let's say, only 2. So in that case, you don't need to bring all the 5 columns or all the 5 fields. And so you can use the projection to delete all the unwanted columns from the relation or from the table. So that is also that. We are going to take that them one by one. And we also have cross product. Cross product allows us to combine 2 relations. It's supposed to allow us to combine 2 relations. Don't get confused with this definition and the union. So when you get the example, you understand better. Now the next one is difference. You see, when we talk about the difference, we are looking at the tuples that are in relation 1 but not in relation 2. So tuples, let's say relation 1 minus relation 2, then it means you are looking at the tuples in relation 1 but not in relation 2. Then union, tuples, so it's a combination. When you talk about the union, then you are trying to combine the 2 relations, the tuples in relation 1 and relation 2. So first, let's look at projection. Projection. We have seen that the moment you say projection, then it means you want to delete unwanted columns or unwanted field, unwanted column from a database table. So for example, we are having S2. S2 will be our relation, or S2 will be our table, and from this side here, so when you consider this one here, we are saying that age projection from S to the age, projection from X to the age, and at the same time we are also, from when you come here, projection from the same S2, but this time we are only interested in S name and the ratings. So, and the results for this one will be this. So because we are only considering the S name and the rating, that is why we said projection enable us to delete unwanted columns. So we are having 1, 2, 3, 4 columns, but this time this command is telling us that you should only consider the columns cell name and the rating. So that is the resultant relation. And this one, when you consider this one too, or when you come to this one, projection from S2, but this time round we are only interested in age. So it's supposed to have only 1 column, because it is being age is only the field that, or the column that has been specified. So the result will be age So like this, age like this. So that is projection. Then we move straight to selection. Selection. So like we said earlier, selection is supposed to select record from a certain table based on a certain condition. So it's supposed to select rows that satisfy selection condition. So for example here, we are saying that we need to select from, this is a symbol for selection, and we need to select from table or relation S2, but this time a condition is being given. We are not going to bring all of them, but we are only interested in those records that satisfy the condition, and the condition here is that rating must be greater than 8. So when you go back to the S2 relation or S2 table, you could see that only UPA and Rusty are having their ratings greater than 8. So those ones that are less than 8, you see that they are not part of the relation. So that is why we are saying that the selection is supposed to give you a row, a records that satisfy a certain condition. So this time round, you are having about four people or 4 records, but this time, because of the condition given that the rating must be greater than 8 from the table 2, then it means only Yupa and Rasi are having 9 and 10, which are greater than 8. So that is the results table or the resultant table. Now, you see, when you do something like this, it can also happen that after performing these operations, you are not interested in all the fields. So if you are not interested in all the fields, but you are only interested in, let's say, an aspect like surname and rating, then it means after performing this action, then you need to project this one so that you can get those one that you are that are interested to you. So for example here, I have there's a command here. This one you need to consider the inner. You see, when you are performing mathematics, you always need to consider the innermost bracket before you consider the outermost bracket. So we need to consider rating being greater than S2. So what we are saying here is that select from table S2 where the rating is greater than 8. So, and this is the result that you're supposed to get, the result table that you're supposed to get. And after getting this table, then we are saying that we are not interested in all the fields, but we are only interested in the surname and the rating. So, because of that, then you need to have something like this, only this, only this, only this, only this section. And that one will give us a result of UPA 9, Rusty 10. So that is the selection. Now you want to look at union, intersection, set, difference. So all of these operations take 2 input relations which must be union compatible. What we are trying to say here is that before you can add or before you can find the intersection of something or the difference of something, then you must have at least 2 entities that you can find their union or intersection or difference. So you want to go back to set theorem, then you can say that maybe set A and the set B, and you want to establish the relationship between them. You want to find the union between them. You want to find the intersection of it, or you want to find the difference. So for this one, you can only have, or you can only perform the following functions or commands if and only if at least you are having 2 inputs or 2 relations. So as you can see from here, we have S1 union S2. So it means we are considering S1 being the first table over there and S2 being the second relation over there. Then before you can perform any of these operations, then number one, we need to make sure that they have the same number of fields. We need to make sure that they have the same number of fields. If they don't have the same number of fields, then you cannot say they are compatible. But we can only perform these operations if they are compatible. And again, you need to also consider the fact that the two fields or the two relations are having the same data type. I mean, the fields must have the same data type. You don't want a situation whereby this is a double and this one will be maybe character, and you want to perform. No, it's supposed to be the same. So, for example, let us look at union. Union here. Now, when you take the union, the symbol is like the one that you know from the basic mathematics. So S union S1 union S2, then it means you need to combine the two. Now, one thing that you're supposed to take note here is that we are just combining all the fields, all the rows together. So when you go back to our two tables, let me go back a little so that you just visit the tables. So the two tables, so we have S1 and S2 as our table for discussion. Now, when you have here, you have 1, 2, 3, 4, 5, 6, 7. So what is happening is that for the union, what is happening, if you don't want any trouble, then you can, since you are performing the addition between this and this, we can just pick the one that is having more records. So when you take the one with more records, then you can see the S2 is having more records. And therefore, we can consider, you can pick all the members, all the rows, all the records in S2. So once you have that one, then what will help you to do is that, you see, you need to look for the common ones. So when you look at 58 Rusty 1035, you can also have 58 Rusty 1035, and therefore you don't need to repeat that statement or that record again because it's already in S2. In the same way, you move to 31 Laba 855. So this one too, you don't need to repeat it again because it is already in the S2 relations. But the 22 is not there. Therefore, you need to add this one, this 22 here, to the S2 table to get the total S1 union S2. So that is how it's supposed to be. So let's move on. Let's move on. Let's move on. Let's move on. So S1 union S2, we were supposed to have 7 members, so 3 from S1 and 4 from S2. But you see, there were two common identities or two common records, and therefore that is why we are having 1, 2, 3, 4, 5. So that is the union. So now let's move to the next item, which will be intersection. So S intersection or S1 intersection S2. So like you saw from our illustration, you saw that 31 over 8 55 and 58 Rasi 10 35. You can find the following item here in both S1 and S2. So the resultant relations will be 31 over 8 55.5, 58 Rasi 10 35.0, because when you go to relation S1, you can have the following table, the following records over there, and when you come to S2, you can have the same following records there, and therefore the S1 intersection S2 will give us this table. Now the next item is the difference. We are saying that when you talk about S1 minus S2, then we are saying that those items that are in S1 but not in S2. So that one, when you consider the two table, then you'll be given this. So it will be like the intersection minus S1. So the intersection relation minus S1. Or so when you cancel all the intersection from then the from S1, the record that left will be the difference between S1 and minus S2. So as let's go back to our table and see our two relations and see whether everything is okay. So as you can see from here, this one and this one are common. So the relation, the records left in S1 will be 22-745. So in the same way, if the question was S2 minus S1, you pick the intersection, that is 31 laba and 58 rusty here, then for Gupa and Upa will be the result stand if you are to look at S2 minus S1. So that is minus or difference for you. Now let's move on. So difference is that S1 minus S2, then 22-755 will be the result. Product. Then the next action or the next topic will be product. So when you take the product or the multiplication, each row of S1, because if you are talking about S1 against R1, then it means when you pick each row of S1, then you pair with each row of R1. Each row of S1 is paired with each row of R1. So it's because it's a multiplication. For example, if here is 3 and here is 2, then obviously you're supposed to get 3 by 2 is 6. So taking S1 3 times, so S1 here is going to be S1 against this one, the first row, and S1, the same S1 against the second row of this one. Then the second row of S1 will be against the first row of this one and the second row of this one. So let's go back to our table so that the explanation, you can get the explanation clear. So this is our table, our table for illustration, and we are saying that you want to find the S1 against R1. So what you are trying to say here is that you take the first row of this one, then you multiply against, or if you pair against the first row. So the 22-745 is going to have 22-745 against 22-101-10-10-96. Then the same 22-75-45, then the same you pair with 58-103-11-12-96. Then you finish you finish with 22 dozen. So we are having two rows now. Then you come to 31 laba 855 is going to be paired against the, so we are going to have 31 laba 855 22-101-10-10-96. Then the same 31 laba 855 you pair against 58-103-11-12-96. So now this one is also going to produce two rows, making 4. Then you come here 58 last rusty 1035. Then you pair against 22-101-10-10-96. Then the same 58 you pair against 58-101-11-12-96. So that is the cross product between S1 and R1. So let's see the results. Let's see the results. So let's see the result for the cross product between S1 and um, S. So that is Dustin 22 Dustin. So here we are having the first row pair against the 2, then the second row of the S1 pair against the same thing, then the last row 58 Rasi pair against this one. So that is that. Now when you do that, there's going to be conflict between some fields. So here we are having SID and SID. So because of this, there's going to be confusion here, because you cannot have two fields with the same name, and therefore we need to rename one of them, or we need to rename the two. Let's say SID1 and let's say SID2. So let us look at renaming operator. So what is happening here is that we are going to consider the first column. This is first column, as we are going to rename it as SID1. Then this one here is the column number. So 1, 2, 3, 4, 5 is the column number, and that one we are going to rename it as SID2 from the cross product of S1 against R1 and S1 against or S1 product R1 is this result. So that is how you can rename this one to avoid conflict. Now the next one is joins. The next one is joins. And this is the symbol for joins. In the actual sense, the joins is will give you the same, if there's no condition attached, will give you the same results as the product. If there's no condition being set there, then the two supposed to be the same. So you see this one here. What we are trying to say here is that you want to join S1 and R1. But the idea here is that we are only going to join based on those S1, SID from S1 being less than R1 SID. So as you can see, when you take the two, it is only going to give you the product. Or let's go back to the product. You see the product, you compare those ones that are less than, whereby the SID here is less than this one. So we are going to pick this one as 1, and 31.25 is greater 31.58. So this one too is, we are going to take this and this. After performing the cross product, so you see 22 is less than 58 and 31 is also less than 58, and 22 is not greater than, or it's not greater than 22, so you just leave that one. So it's going to pick the Dustin and Laba as the answer. So joins for this one, Dustin and Laba will be the resultant. So this is the symbol for the joins. But the join here, we are setting a conditions. So if there's no condition, then it will give you the entire R product S. But this one, the condition is being set there, where the SID is greater, the SID of this one, and SID is greater than the R1 SID. So that is that. Then we can also have equijoint. The equijoint is a special case of condition joint where the condition contains only equalities. So like this one is going to, so it's going to consider this one. So but yeah, we are only interested in the area whereby the ages, or they have common attribute. So that is that. So that is equivalent. So I think we have exhausted all the time, and therefore we can end our lecture here. We are going to continue next week or next time. Thank you very much for having time with me, and I believe you are going to enjoy this tutorial. Thank you very much. Bye bye.